Hi guys, NERC Professor here, July 10th, 2024, 7 in the evening, Eastern. A lightning arrestor fails on a 230 kilovolt transmission line. The protection system does exactly what it was designed to do. Every fault clears correctly, the slowest one in 66 milliseconds. And then 1500 megawatts of demand vanishes from the Eastern Interconnection in seconds. No generator tripped, no utility breaker dropped a single customer. The grid didn't disconnect that load disconnected itself. Less than 2 years later, that event and the ones like it have produced the strongest tool in NERC's alert system, a proposal for an entirely new kind of registered entity and a standards project moving on a timeline NERC almost never attempts. This is the large load story: data centers, crypto mines, AI campuses. If you plan, operate, or own transmission anywhere near one, this episode is for you. Quick disclaimer, the full text is on the screen. I'll pause a few seconds so you can read it. Let's slow the event down, because the details are the whole story. A lightning arrestor fails. The line faults, and the fault is permanent. Protection clears it. Then automatic reclosing does what automatic reclosing does. This line was set for 3 reclose attempts, staggered at each end. Each shot closes back into the fault, 6 voltage depressions in 82 seconds. Every single one cleared properly. The dips lasted between 42 and 66 milliseconds. In the area around the fault, voltage sagged to between 0.25 and 0.40 per unit. Now, here's the question that matters. Routine fault, normal clearing, standard reclosing practice. Operators see this every storm season. So why did 1500 megawatts of load walk off the system? Hold that thought. The answer is sitting inside the data centers. A data center has one design priority: protect the computing equipment. Voltage trouble damages servers, so every facility sits behind an uninterruptible power supply. Some use big centralized UPS units, 2 to 5 megawatts each. Some use small rack-level units. Some use rotary systems, flywheels coupled to diesel engines that physically separate from the grid and do not come back until someone reconnects them manually, and many facilities run a protection scheme that counts voltage disturbances. The typical setting: 3 disturbances within 1 minute, and the facility transfers to backup power and stays there until a human transfers it back. Now replay the event. The initial fault, then the first reclose. That's strike 2. The next shot, strike 3. On the third voltage depression, the counting schemes fired. About 1260 megawatts dropped off the grid on that shot, and it did not come back for hours. Everyone's mental model says the grid sheds load. Here, the load shed the grid, and the equipment on both sides did exactly what it was set to do. That's the uncomfortable part. Nothing malfunctioned. Here's the thing, losing 1500 megawatts of load looks like losing 1500 megawatts of generation mirrored. Frequency rises because generation suddenly exceeds demand. Voltage rises because less power is flowing. This event stayed benign. Frequency peaked at 60.047 Hz. Voltage touched 1.07 per unit, and operators pulled shunt capacitor banks to bring it back down. Fine, but watch this. Our planning framework was built around losing generation. The system has never had to plan for simultaneous load losses of this size because load never behaved this way before, and this was not a one-off. ERCOT has seen numerous unexpected load reductions during disturbances, mostly power electronic load at crypto mining and oil and gas facilities. When operators tried to investigate, they hit a wall. These loads are not registered entities. No reliability standard applies to them. Some of their protection wasn't visible in anyone's models, and there is no voltage ride-through standard for load. None. The 2024 Long-Term Reliability Assessment documents how fast this class of load is growing. Some of these facilities want to connect in months, not years, so NERC moved. Watch the cadence here, because this is the fastest escalation I have covered on this channel. August 2024, NERC stands up the Large Loads Task Force. January 8th, 2025, the incident review publishes, and it openly asks, should large loads be registered entities? Should the standards change? February 2025. The NERC board passes a resolution directing an action plan. July 2025. The Task Force White Paper lands. Characteristics and risks. September 9th, 2025, a Level 2 alert, industry recommendations on large load interconnection, study, commissioning, and operations. February 24th and 25th, 2026, a dedicated technical conference. March 2026, 3 hits in 1 month. The gap assessment finds existing standards inadequate. The Standards Committee launches Project 2026-02, and the Level 2 responses come back showing entities generally do not have the processes to manage this risk. April 1st, 2026, the Standard Authorization Request posts and the Registry Criteria post. May 4th, 2026, the Level 3 alert, from Task Force to the top of NERC's alert system in 21 months. So what is a Level 3 alert? Under Rule 8.10 of NERC's Rules of Procedure, alerts come in 3 levels. Level 1 is an advisory, purely informational. Level 2 is a recommendation, like the one from September. Level 3 is essential actions. Things NERC has determined are essential to keep the bulk power system reliable. A Level 3 cannot even be issued without NERC board approval. This is the strongest signal NERC's alert system can send. This one went to transmission planners, planning coordinators, transmission owners, balancing authorities, reliability coordinators, and transmission operators. Now, here's what most teams miss. A Level 3 alert is not a reliability standard. There is no penalty for skipping the essential actions. So you can relax, right? Look closer. Acknowledgement was required by May 11th. A full status report is due August 3rd, 33 questions. And NERC aggregates every answer into an anonymized report that goes to FERC, your gap analysis, summarized on the regulator's desk, while the same 7 actions are being written into a mandatory standard right now. The alert is the standard's first draft, in everything but enforceability. The 7 essential actions split cleanly. Actions 1 through 3, know the load before it connects. Action 1 is modeling, transmission. Planners and planning coordinators build a detailed list of the model. Data computational loads must hand over, and transmission owners bake it into their facility interconnection requirements. The baseline is the PERC 1 model, power, electronic reconnecting and ceasing. IT load modeled separately from the cooling load, UPS settings and configurations. Maximum ramp rates up and down, the voltage and timing at which the facility trips and when it reconnects. Even what the facility is used for, because AI training behaves differently from crypto mining. Action 2, study it. Work out how much computational load each area can absorb before voltage or frequency instability. And here's the planning flip. Build credible contingencies for losing the load. Put them in your contingency files, and tell your balancing authority the megawatt number. Action 3, planning coordinators rewrite their definition of qualified change. Growth counts, settings, changes count, and repurposing counts. A crypto facility converting to AI training is a different electrical animal. Restudy it. Actions 4 through 7, prove it and watch it. Action 4, commissioning. Transmission owners establish a real commissioning process. Verify the as-built model. Notify neighbors on the same point of common coupling. Full load and no load testing, and where possible, a voltage swing test, 10% up and 10% down, with the computational equipment installed and running. Action 5, ride through. I'm giving that one its own slide. It deserves it. Action 6, recording. Transmission owners put dynamic fault recorders at these facilities. Continuous low-resolution recording plus triggered high-resolution recording. And they share that data up the chain for event analysis. Remember, in the ERCOT events, analysts could not even see what the facility protection did. Action 7, communication. Operators establish interpersonal communications and joint operating procedures with these facilities, and issue instructions by voice or SCADA to prevent emergencies. The era of the silent gigawatt customer is over. Now, Action 5, the part of this alert nobody reads carefully enough. Transmission planners and planning coordinators working with transmission owners should study and fix the system side so that a normally cleared non-bus fault causes no non-consequential loss of firm load for computational load. Read that again. A routine fault should not knock firm data center load off the system. That is TPL1 performance language pointed at a brand new problem, and on the customer side, transmission owners should coordinate improvements that maximize the facility's ride-through up to what the equipment can take. Sound familiar? It should. In episode 2, we walked through PRC 29-1, where regulators forced inverter-based generation to stop dropping off the grid during routine disturbances. Same disease, other side of the meter. Generators that quit during faults got a ride-through standard. Loads that quit during faults are next. Everyone still reads ride-through as a generator topic. This alert says otherwise. And now, the structural change. NERC is proposing a brand new registered entity, the Computational Load Entity. 2 new definitions. Computational load, load comprised of electric power demand from information technology equipment such as servers, storage, and networking hardware. Computational load entity, the end user or the entity that hosts end users, that receives electric power for computational load. Who has to register? 3 thresholds, and you must meet all 3. 20 megawatts or more of aggregate connected load capability, a single point of interconnection to the bulk power system at 60 kilovolts or above, and 1 megawatt or more of computational load. If 20 and 60 sound familiar, they should. That is the same numeric pattern PRC 29-1 uses for inverter-based resources with megawatts in place of MVA. NERC is rhyming on purpose. The proposal rewrites Appendix 2, Appendix 5A, and Appendix 5B of the Rules of Procedure. Public comment ran April 1st through May 15th. NERC intends to finalize the registry criteria by the end of 2026. Data center operators who have never heard of NERC compliance are about to meet it. The standards piece is Project 2026-02. The SAR is titled Reliability Standards to Address Computational Load, Phase 1. It went in on February 20th and posted April 1st. The plan, one bridge standard collecting the essential actions in a single place, fast. NERC expects an initial standard by the end of 2026. Then, beginning in 2027, Phase 2 starts folding the requirements into the families you already know. MOD for modeling, PRC for protection, TOP and IRO for operations, COM for communications. The bridge standard retires as the permanent homes get built, and a 100-member advisory group stands behind the drafting team. NERC has put this timeline in writing to its regulator. In March 2026, it sent FERC a supplemental letter committing to revised registry criteria and reliability standards by the end of 2026. FERC, meanwhile, has its own large load proceedings running, including the co-location docket NERC has filed comments in. The reliability track and the market track are converging on the same buildings. So what should you actually do right now? 1. If you are a transmission planner, planning coordinator, transmission owner, balancing authority, reliability coordinator, or transmission operator, your Level 3 response is due August 3rd. 33 questions, and a valid response takes all 3 steps in the alert system. Acknowledge, submit, approve. Don't let it die half-finished in a queue. 2. No data centers in your footprint. The alert still covers you if you could feasibly receive a request in the next 2 years. NERC's guidance is blunt. Have this in place before the first interconnection request arrives. 3. Start collecting the action. 1 model data now and update your facility interconnection requirements. Every month you wait is another facility connecting under the old rules. 4. Put loss of load contingencies into your planning cases and give your balancing authority the number. 5. If you operate data centers, check yourself against the 3 thresholds. 20 megawatts, 60 kilovolts, 1 megawatt of IT load. If that's you, registration is coming and mandatory standards come with it. Join the ballot body. Comment while the text is still wet. 6. Watch Project 2026-02. A standard drafted this fast will have rough edges. The comment windows are where you sand them. Recap, July 10th, 2024. A normally cleared fault, 6 voltage dips in 82 seconds, and 1500 megawatts of data center load walks off the Eastern Interconnection. About 1260 of it stays gone for hours. NERC's answer, 21 months later. A Level 3 Essential Actions Alert. 7 actions. Responses due August 3rd. A new computational load entity. 20 megawatts, 60 kilovolts, 1 megawatt of IT load. Registry criteria final by the end of 2026, and Project 2026-02, with a bridge standard expected by the end of the year. The grid spent 2 decades learning that generation built on power electronics needs rules. It is about to spend the next few years learning the same lesson about load. Subscribe for more episodes on real NERC topics. Stay compliant.